for
chemistry.
Yeah, baby. Yeah.
Welcome to Let's Get to the Marks, going through an organic analysis chemistry A-level question. Let's go! Press pause, guys. So, compound X is an organic compound with two functional groups. Compound X has a percentage composition by mass of carbon, 40.91%, hydrogen, 4.54%, oxygen, 54.55%. Compound X does not decolorize bromine water. So I'm going to put some notes on the sides here. We know it's got two functional groups. That's key. A scientist analyzes compound X using mass spectrometry and infrared spectrometry. We need to, for 6 marks, identify X and come up with the formula and put all of our data down. Let's see how many marks we can get. You might want to grab some scrap paper, have a go at this first part. I'm going to go through the first couple of bits that we can do from this screen, and then we'll move on to the next screen, try to piece it all together and see how many marks we can get. So pause the video, have a go. Okay. First thing we can work out from this, we can work out the empirical formula that's going to score us a mark out of 6 marks. So 40.91 divided by the atomic number, divided by the mass number of each element. So 40.91 divided by 12 gives me 3.41 for carbon, 4.54 divided by 1 for hydrogen gives me 4.54 for hydrogen. And for oxygen, we're going to do 54.55% divided by 16 equals 3.41. We're then going to simplify by dividing by the smallest. So we get 1 to 1.33 to 1. Don't forget with oxygen, it's not as an oxygen gas. It's not 32. It's not O2. It's part of a compound. So you're always going to do 16. All right. Yeah, so the empirical formula is if we multiply these all by 3, we're going to get them into roughly whole numbers, and we're going to get carbon is 3, hydrogen 3.99 rounded up to 4, right? It's basically 4, and oxygen 3. So we've worked out our empirical formula. That has scored us a mark. So C3H4O3, the empirical formula has got us a mark. Now what we can tell also, what else can we tell from the information on this first screen? So let's have a little look what else we can discover. Compound X does not decolorize bromine water. That means it stays orange. What does that tell you? There are no CC double bonds. And you might say, well, how does that help me? Well, it helps us later on when we look at the IR spec. So I'm going to come over here to the data sheet. We'll look at the IR spec for where are alkenes? Where are alkenes? There we go. 1620 to 1680. So if we get any clashes and we start to think, is that a double bond around 1680? It's not. There are no double bonds in this molecule. Oops, wrong paper. Here we are, back again. Right. What are we going to use now? We're going to look at the mass spectrum and find out what can this tell us. The key here is to piece it all together and put your data down. We've got the M peak here, the final line. You do get an M plus peak sometimes, but that's for isotopes and not of interest here. So 88 is the M peak. Let's add up our empirical formula, see what it is. If it's 44, then the molecular formula is double. But if we add this up, 3 times 12 is 36, plus 4 for the 4 hydrogen, plus 16 for the 3 oxygens, we get 88. And that tells us that the molecular formula is also the same as the empirical formula. So C3H4O3 is the molecular formula as well. Boom, we've pieced that together. Isn't that wunderbar? Right, so now we know that the total molecular mass, the MR, is 88. We're going to score more marks for that. Okay, super. We're going to come back to this mass spectrum, okay, because there's other things we can work out from the mass spectrum to do with the specific structure. But I want to look at the infrared data table that they've given us as well, because we're going to learn more things from this infrared data table, and then we're going to go back to the mass spectrum and confirm. I'm going to shrink this down because what I really want is my IR spec and my mass spectrum together on the same page so that I can analyze them both and make any additional notes that I need to make here. Okay, so we've got the IR spectrum of X. Remember that was 88, the MR, and our first thing to look at the IR spectrum down here is that, what is that, about 17, I think that's about 1725, maybe it's 1750, not too sure, maybe that's 1750, right? What we're going to do, we're going to go, okay, there is a bond at 1750. We need to go and check what that bond is. There is a peak, a narrow peak at 1750. Let's look at our data table. Here we go. It's an aldehyde ketone or carboxylic acid. It's a carbonyl group. Okay, so it means it's the COO bond, the carbonyl group of potentially a ketone, aldehyde, or a carboxylic acid. All right. So we now know that we've got the COO. The next, that's another mark. We're gonna be on 3 marks here, possibly 4. I think probably 3 marks at this stage. out of the six. We've now got a broad peak. This is a fat peak here, okay, and it is round about, I don't know, 2,800, 2,900 to sort of 3,300, 3,400, whatever. You're going to write down as evidence in your answer, oh, there's a broad peak at that range, and we're going to go to the data sheet and see what the possibilities are for that. And if we look at the data sheet, we can see that if you get a broad peak, I've highlighted it here around there, it's an OH group, but with a carboxylic acid. Is there any way it could be an alcohol OH group? No, because that peak starts at 3,200 and ours clearly starts before 3,000. So this is the broad carboxylic acid peak. You want to make a note of that, guys. Oh my gosh! Where's all my notes gone? Okay, I lost all of my data just a minute ago when I flicked over. I lost all the writing and all the notes that we'd done going through the video when I flicked over to the data sheet. That happens sometimes. So what I'm going to do is I've quickly paused it, typed out everything as far as we got, and I went a little bit extra. And I'm going to talk you through it again very quickly, going through what we already did and then adding on to the conclusion of this question. So we use the empirical, and the main thing to take away from this is even if you don't get the final structure right, you're going to get 5 out of 6 or 7 out of 8. You can get like A star just from showing your working. So first of all, you show your empirical formula working, and then we simplified the ratio by so we got 1 to 1.33 to 1, and then we times by 3. So what we got is 1 to 1.33 to 1. We times the lot by 3 to come up with an empirical formula of like 3 to 3.99, which is 4, and then to 3. So we got 3 carbon, 4 hydrogen, and 3. We then looked over here and saw that the MR was 88, and that's because that's the M peak was 88. And from that, we deduced that if you go 3 times 12 is 36, plus 4 for the hydrogens is 40, plus 3 times 16 for the O3 is 48. Actually, the mass of the empirical formula is equal to the MR, which tells us that the molecular formula is also C3H4O3. So we also deduce the molecular formula. We want to show that. And then we start to then check out the IR spectrum. And we saw that because it told us earlier there were no carbon-carbon bonds, which is about 1680 or something like that, that decolorized bromine, that helped the confusion. This can't be 1680, a C double bond, so it can't be that because it didn't decolorize. So it's not that. And in fact, the only option is at 17, sort of 20, 50, whatever, you've got the carbonyl group. So we know it contains a carbonyl bond. Now, is that just a ketone or is it a carboxylic acid? Well, we come over here and when we looked up on the data sheet, we saw that this is an OH group, but it's not just a normal OH, it's a broad peak. That means this is wide or broad. Okay, so it's a fat peak, and that fat peak means that it is an OH attached to a carboxylic acid potentially. Now, you might say, but could it also have an OH, a hydroxy group coming off somewhere else in the molecule? Well, that should have had a thinner peak here. There should be a long peak here starting about 3,200 or 300. So it would extend over a bit. So it probably doesn't have an alcohol group. It's probably definitely a carboxylic acid. And that means that it contains this. We can confirm it contains COOH because of these two facts. So you want to note that down. IR peaks, they confirm that. You want to identify what it is. Even if you can't work it out, you'd say it's got carbonyl group because of that. It's got an OH group for a carboxylic acid because of that. It's going to contain COOH. Now, we know that there are 3 oxygens in the formula. So, and we were told in the question, which I didn't put anywhere when I was rewriting this out, there are 2 functional groups. Do you remember we were told that further up in the stem of the question? There are 2 separate functional groups. Well, this COOH is just one functional group. So there must be another functional group, and that functional group must contain an O because there's 3 O's in the formula and only 2 are used in the carboxylic acid. So we're looking for another O. It could either be an OH, but I don't think it's going to be an OH. It could be the COO because there could be 2 of them here, right? So that could represent the one in the carboxylic acid and a separate carbonyl group, like for a ketone or aldehyde, sticking on there. So I'm going to piece together the formula and we're going to go back over here and we're going to say, okay, so, we could make a prediction and go, right, well, if I've said there's 3 carbons, well, and we're going to stick carboxylic acid has to be at one end. It can't be in the middle. And then we go, right, well, I can either put a carbonyl group there or I can put it there. Let's do an aldehyde like that. And that covers. And then we could add this up and be like, okay, 3 oxygens, 48, 4 hydrogens, beautiful, and 3 carbons. It fits the blooming formula and the bonding's all correct. So that would be an ideal thing. And then we say, well, can we match this with the MZ peak? So we say, okay, let's break this bad boy bit off and add up that. And look, at 43, we get this huge peak here. And how much would this be? Well, you get 16 for that. You get 24 for the 2 carbons. That's 40. And then we get 3 for those 3 bad boy hydrogens. That would all add up to 43. So that would make sense that you get this fragment. Now, don't forget the positive charge, because these mass spectrometry, you end up with positively charged fragments. So this is going to be one of the fragments at 43. We've just identified it. Wunderbar. Now, if you have a carboxylic acid group like that, we can confirm what that would be. Look over here at 45. There is another peak there. And of course, that is going to be, this is 16, that is 12, that's 28, that's 17 for the hydroxy. I can't even add up whatever that is, 28, 38, 45. So that would be this peak down here at 45 is going to be the carboxyl group with a positive charge. So COOH plus, and that's that group. Now we piece it all together, and my final formula I'll rewrite out again for you. I'm going for this structure, but there will be multiple that you could have on the mark scheme that will add up. It's just like kind of playing around with it and then justifying it. Sometimes you come up with it and then you can look and check it on there to see does it make it. Yeah, have I got 1 2 3 4 1 2 3 4 1 2 3 4? Yeah, so that's my final formula, guys. All right, I hope you found that organic analysis useful. Don't forget, sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks. It massively helps me if you hit the like. And if you don't hit the like, you know what I think you are? I think you're a molybdenum fluoride. So don't be one of them. Make sure you hit the like, because it helps me. And hopefully I'm helping you. All right, guys. Catch you in the next vid.
You're still here? It's over.